on chapter 3, and I have a feeling I forgot to go in here and erase my chicken scratch. I did, so clean that up real quick. You can see I didn't make it actually take a lot of notes this time because it's a lot of building things. I have everything kind of built. So today my goal is to kind of get through 3.1 and maybe a little bit into 3.2. And then we'll stop there, and then we'll do 3.3 and 3.4 next week. So chapter 3 is logic statements and kind of this truth tables. It is very similar to chapter 2, which is set notation. So we're going to talk about some of the very, not same, but very similar concepts. So some of the wording is going to be the same. And then some of them are, the symbols are going to be different, but the wording's the same. And Zach, to answer your question, yes, I will do some truth tables in the video. And we're going to do some today by hand too. So you'll have today's lecture of ones I've created on my own. And then probably maybe this weekend I'll go through and do a chapter 3 recording of me doing some of the truth tables on the Hawks, so we can kind of answer the same questions. So first we got to understand what statements are, right? And so this is kind of where grammar and math kind of come together. And when they do, we call it logic, right? And so, and logic statements, and so 3.1, just like everything in almost all of our chapters, the first section's a bunch of definitions, right? So I pretty much took the words right out of the book, but I'll try to explain them if they're not clear. And that's kind of what 3.1 is. And then 3.2 is actually building these truth tables. So 3.1 is a complete sentence that asserts a claim that is either true or false, cannot be both, right? So a statement does not always have to be true. It has to fall into that it's one or the other. It is either fully true or fully false. It cannot be both. And when I really kind of get into what makes something not a statement is almost an opinion. Right, and so that's where kind of you got to ask yourself, is it an opinion or not, right? A paradox is a sentence that contradicts itself and has no single truth values, which means it cannot be a mathematical statement, which basically means I cannot create a truth table of it, which is in 3.2. So here's some examples of some statements that are paradoxes or neither, right? So example, the Patriots won Super Bowl 50. That would be a statement, right? Because no matter how you feel about the Patriots, they did win the game, right? So therefore it is a true sentence. It's a complete sentence, and it is completely only true. So that is a statement. Tom Brady is the GOAT. Now, some would argue that this is a statement, but it is really not, right? Because it is an opinion, because we haven't had a mathematical way to articulate that someone is the greatest of all time, which is what the GOAT stands for. So it is neither, right? It doesn't contradict itself, but it doesn't have a claim of either true or false, right? Because some people say that is true. Others will say, I forgot his name, Mahomes from the Chiefs, right, is the greatest quarterback. So it really comes down to who your team is. And there's probably some teams that would argue that your quarterback is not good at all. So definitely you shouldn't argue that they're the greatest of all time. But it is not a statement, right? Even though it's a complete sentence, because it does not have a complete truth or a complete false. It is neither, right? So I guess I could write these down in case someone goes back and looks at the notes later. So this one is a statement. This one is neither. All right, I do not teach any humanities classes. Is that a statement, paradox, or neither? And so this one is also a statement because I do not teach any humanities classes. That is a fact, right? So it is truth. It would also be a statement if I said I do not teach any math classes. It would still be a statement. It would just be a false statement because I do obviously teach math classes. So again, a statement doesn't always have to be true. So this is also a statement. It just has to be one or the other. Now the last one is a paradox. Does anyone see why that is a paradox? How does it contradict itself?
Word all.
All? Okay, yes, the all is definitely part of the issue, right? So the reason this is a paradox, unless someone else wants to explain it, which I wait a minute to see if someone wants to.
Is it because you're putting everybody in one group as people?
Sorta. Because think about it. So if I say people lie all the time, and that means I'm a person, right? So if people lie all the time, then that also means that I'm lying, right? Because I'm a person. Well, if people lie all the time, I'm lying, then that means that's a true statement, which means people tell the truth, but then I just said I'm lying. See how it contradicts itself? Because I'm the one saying it. So if I say people lie all the time, I can't say that if people lie all the time, because then I'm doing the opposite, which means people tell the truth all the time, which then relates back to that this is not. So you see how it contradicts itself? Because I can't, if I put people lie some of the time, then that would be a statement. But because exactly, I don't catch who said it, but the word all, right? Because there's no room for error there, right? Because if people do lie all the time, then it means I can't be currently telling the truth, which now I just contradicted myself. So that is a paradox. I tried to go through and pick decent ones because sometimes these are very argumentative. So when I create the test, I try to be very careful which things I ask on these because there's times that even Hawks I don't agree with sometimes. So don't get too wrapped up sometimes. You can email me if it gives you one. Because I don't get to pick. I just say, hey, give them a statement problem or give them a paradox problem, but it scrambles the statement so I don't get to see everyone's statement. I try, so on the test, I'll make sure that I try to review that, but just don't get too frustrated if some of them are kind of questionable. But you can take me a quick shot, like, I don't think this is correct, and I'll look at it like, yeah, I agree with you, or I'll explain why, because some of them are kind of argumentative at times. And we can see why with today's society of what is actually really a fact anymore or not, depending on, I guess, what side of the fence you stand on. All right, a negation is the logical opposite of the statement, or its denial, basically the opposite, right? So a negation of A is the Patriots did not win Super Bowl 50, right? It's the opposite. They win or they did not win. Tom Brady is not the GOAT. I teach some humanities classes. People lie some of the time, right? And sometimes when you do the opposite, you actually end up fixing the problem, right? So what is really interesting, and I took this right out of the book, is really careful with the wording, right? Because I still get these wrong at times. And so that's why I like to always refer back to this table. So when you do a negation, all you need is one thing to contradict, to be the opposite, right? So all doesn't go to none, right? All, if I want to negate it, goes from some, because all I need is one. I don't need everyone to be the opposite. I just need one to be the opposite, right? So this table kind of helps with your negation. So if your statement has an all in it, then some of the negations are not all, some are not, or at least one is not, because you just are looking for that one opposite to make it not the same statement. And if you use the word some, there is where you get to do the opposite of none. then you got the some are not, and then all are, and then none are, and there is. So this table will help. I would definitely keep this for when you're doing, if you are doing the Hawks as your grades, or when it comes down to the test. That will help you find the right negation statement, because a lot of times, a lot of the answers I see is I will give a statement that has the word all in it, and the most common answer that is wrong, they pick the one that has none. They go to the extreme end. But again, I don't need to get everybody to be the opposite. I just need one to make the statement the opposite. So be very kind of careful with that. Compound statement. So now this is where we're getting into project 3. So for people that want to do project 3, there's 2 choices. If you do the book project, I know a student has, and I'm not going to bring it up here, but if the student wants to say they can. They did a really good job. They did the light bulb project, first time ever. So that is the books project of this. The one I created, which some students typically do, is if they don't want to do the light bulb project out of the book, you can also create your own statements and truth tables using the social media aspect. So if you're considering doing that project, this is where you want to kind of start looking into this, how we're going to do this. And so the first part of that project, the social media project, is to create a compound statement, right? And so a compound statement is just 2 or more statements joined together using our favorite words that we've already learned in, well, some of them, we learned a new one today in chapter 2, the word and, or. I don't know, it's weird seeing or. It's challenging writing logic statements with proper grammar. So that's why I italicized one R. So our logic statements will either be an and statement, an or statement, or an applies statement, right? So the implies is our new one. We talked and or, and not. I guess I could add not in here. That's one that's missing, because that also can make a compound statement. Let me go home, add that in right now. And or not or implies. Now that my 2 ors aren't next to each other. Oh, I got to italicize not though, because that is one of our words. No, it was italicized. Perfect. So you're going to create statements using that conjunction. It's and or not implies, and it can be more than one, right? So for that project, you got to come up with a compound statement to build a truth table. So you're going to, I think I tell you to create 3 statements of social media. And then what you do is create a compound statement. And what statements you do on social media is completely up to you, right? We're basically I want you to compare different platforms. So there's all kinds of them out there, which whenever you use, Facebook to TikTok, Facebook to Twitter, whatever all of the new ones are. I don't use really any of them, but if you do, and it's something that interests you, then this is a good project to apply what you learned in class into something that interests you, right? And so one of your statements can be, if you're a Facebook, if you use Facebook, then you also use Twitter, right? So that's a statement, compound statement. I'm comparing Facebook to Twitter, and my compound is then, which is what implies is, which we haven't quite got to yet, but we will. So kind of keep that in mind if you want to do that project. So here is an example of 2 statements. I guess I can update this thing since we are the spring semester now. So you can see I didn't change my notes from the fall, so we'll call it spring. So the spring semester it has started at CMCC. Math 150 Quantitative Reasoning is a new math course. I guess I got to take new out. We've been going for a year now, so we'll just take out the word new. So is a math course. There we go. And so those are statements, right? Because they're true. The spring semester has started at CM, right? Because we're all in class right now. And no, it doesn't feel like spring outside. It is called the spring semester. So that is a statement. And 115 Quantitative Reasoning is a math class. And you all can vouch for that because you're sitting in this lecture right now and taking a math class, right? So these are both statements. And so now what we want to do is find, and so you notice I label my statements with the lowercase letters. So statement A is the spring semester has started at CMCC. Statement B is Math 115 Quantitative Reasoning is a math class. I think for the project, I want you to come up with 3 statements. And They are completely up to you what they are. And then here you go where we start the project piece. So I want you to write the statements for A and B, A or B, A and not B, and B applies A, right? And so what applies means, which I think I have in this table here, is one thing leads to another, and usually that is a if, then, or then statement, right? And that is the implies. And so what this table shows here before we get into the statements is the symbols, right? Because the symbols can be a little confusing. And I still have to relate back to this. I actually, in the video that I did for chapter 2, I purposely was on one of the problems and I jumped between hawks, opened my OneNote and came to this table, because if you forget the symbols, then go to your notes, right? Either write it down or have this index so you can go to it quickly. But the differences here, the words are the same between chapters 2 and 3. We have an and, we have an or, and we have a not. So in chapter 2 in set theory, and was the upside down U, or was looks like a capital U, and not was, I think it's called the tilde. I keep calling it a little tilde, but little tilde on the keyboard, right? Or an asterisk, I think tilde is a logic statement, but either way. So you can see when we get to logic statements, they're very close to being the same, except for logic statements turn them into V's. So set theory, they're U's, logic statements, they're like V's, but what they represent is exactly the same. And is and, means both must happen at the same time. So though the symbol has changed, what and has not. And means they both must happen at the same time. Or means at least one of them is happening, right? And the not is the opposite. And then implies, we didn't do implies in chapter 2, so there's no symbol for it. And then in logic, it is an equal sign with an arrows, right? So there is the symbol. So if you see the symbols, this table lets you put words to the symbol. And I think in the video I created for Hawks, I literally wrote on my screen above the and symbol, wrote the word and, right? So on the test, or you're doing it on your notes, if you don't want to use the symbols, then just write the words there to remind you what they represent. So that is very useful when you're doing the assignments, because it lets you put it into grammatical. And then, so now what we can do is we can create our statements. So what I've done over here is created the statements. I guess I got to update them so we can update them here at the same time. Instead of writing my horrible handwriting, I'm just going to type. So our first statement is the spring semester has started at CM. And I literally just took the first statement and I put it with the second statement and put an and in between them. So the spring semester has started at CMCC, and Math 115 is Quantitative Reason is a math course. So don't overthink this. It is just throwing an and in there. Or the fall semester has started at CMCC. Well, again, let me fix that to spring. The spring semester has started at CMCC, or the quantitative reasoning is a math course. A not statement, the fall spring semester has started at CMCC, and Math 115 quantitative reasoning is not a math course. Right? So when you create the statements, you're not saying, well, it is a math course, right? But remember, you're writing the statement for the opposite, right? So don't get hung up like, well, it is, so why would I write this? It's because we want to make sure we know how to use our sentences. Tanner, question?
Nope.
Okay, I just saw the hand up, so I wasn't sure. All right, so the if-then statement. So Math 115 quantitative reasoning is a math course. Therefore, the spring semester has started, right? So there's the implies. So therefore, then, if then, those are all imply statements. This leads to that. That is kind of what implies means. So finding that grammatical word that kind of means implies, and just making sure that you write a good grammatical sentence kind of thing. Sorry, I hit my mute button. And I'll tell you right now, grammar is not my friend. As somebody, you say you have math anxiety and don't like math, words are not my friend as much as math may be not yours. And I'll blame the fact that I learned how to write everything in symbols. in shorthand, so that's probably why I cannot spell anything, because everything was always written in computer code and symbols, which nothing spelled correctly. So you may find errors in my stuff. So please, if you find them, let me know so I can correct them. Typically in the classroom, and I don't mind doing it here. If you find an error and you correct me, I will give you what I call bonus points, and I just add a point to your test. And trust me, I've had some English majors who've gotten lots of bonus points correcting my mistakes. So I don't take offense to it. I do it for two reasons. One, so I can also learn, and two, to show that we all make mistakes and we can kind of learn from them. So never be scared to ask questions or be wrong. So any questions on, I'm making sure I haven't missed anything. Logic statements and how to create statements. I think the key takeaway from this section really does come down to this table of knowing your symbols, which again is both chapter 2 and 3. Knowing how to write negations and knowing what a statement or paradox is, right? So that's the kind of the big takeaway from 3.1. So no questions? Okay. Truth tables then. Sorry, I get a drink here. My voice is going hoarse. All right. So a conjunction is a combinations of statements using and, right? So again, some more definitions here. So and is only true if all statements are true, right? So this is really where it comes down to how to build a truth table. Think of a truth table as like a Venn diagram, right? Again, they are not related at all. So don't think that you can use a Venn diagram to create a truth table. I'm not saying that. But remember, what does a Venn diagram do? It allows you a graphical representation of the analysis as we were doing, right? A truth table is the same thing. I can write everything in logic statements and put it in words. A truth table is a graphical visual or a picture of those statements, right? So that's kind of the same. I'm just taking one and I'm creating basically this table of those statements. And while I'm talking statements, so if you do the chapter review for chapter 2, I don't think the Moby Dick, I forgot the other books now. I can't remember the other two titles all of a sudden. I've done this probably like 3 times with students. Anyway, if you've actually went and did some of the practice hawks and you're in the sections, there is a book Venn diagram. Be very cautious with that one. The words go into the statements where you got to be really careful with the negation statements. The first time I did it with a student, we got it wrong because I missed a word. So pay attention to the words. It is not on the chapter review. So if you're not doing the sections, you won't even know what I'm talking about. But if you actually go and do some of the section homework assignments, you'll run into that book problem. That is a very challenging problem. So don't get frustrated if it hangs you up for a minute. But if you get through it, then I'd say you have a very good grasp on Venn diagrams. That is a very good, tough one. The one I would definitely review. So even if you are doing the projects, there's one about traveling to Germany, Spain, and France. You'll probably see that problem again, no matter if you do projects or hawks. So there's the hint. Make sure that's a good problem to review. And you'll see it again more than once. So, okay, perfect. I think we can get to that. And I still owe you answer to that one problem. I kind of figured it out. I don't like it, how I'm going to explain it. So you picked a really tough problem, but I understand what they're asking now. So I owe you that at the end as well. Kimberly's asking questions in chat. So I'll get to those at the end. So and is what we call a conjunction. And it is only true if all the statements are true. Or is a disjunction, and it is always true unless all the statements are false. Basically, it's saying at least one must be true. And again, this doesn't make quite sense yet till we get to a truth table. Conditional is a combination of statements using if-then, right, which is the implies. So an if-then is always true unless the if is true, then false. So if it falls in that order, this will make it conditional false, all right? And so the way the book says it, it says, look at it as like a promise. And so the only time you break a promise is if you do the first part, but fail to do the second, right? If and only if is true when the statements you are comparing are both result in false or both result in true. So these are what I'm putting in here. These are kind of shortcuts to creating the truth table is basically what they are. And so just to explain the promise one, because this seems to be the confusion of them both. So here's a little bet we have. If the 49ers win, then I pay you, right? So you bet the 49ers win, I bet the 49ers lose, right? So if the 49ers win, I pay. If the 49ers lose, then I don't have to pay, right? So 49ers win, I pay you, then I did what I was supposed to. That's a true. 49ers lose, I don't have to pay you, so that is still true. The 49ers lose, I can still pay you out of the kindness of my heart, right? I don't have to, but I can, so that is still true. 49ers win and I do not pay you, now I am a jerk, and so therefore this is where you break the promise. You said you were going to do something, the statement happened and you went back on it. So this is the only time an if statement becomes false. All right. So these basically are rules to help you create your truth table. So an example of a truth table, and we'll leave this one like it is. It's fine. We'll change it. It's always good. Keep us updated. The spring semester has started. Quantitative Reasoning is a math class. So we use those same statements that we had before. Now we're going to put them into a table form. So I have it complete here, but I'm going to do it out again. All right. So do I want to draw or just erase? I'll erase. And then we can just recreate it. So when you first start your table, what you should do is start with create a column for each statement. So we have two statements, so I have two columns. And then this is the pattern I use. I do true, true, false, false. All you're doing right now is you're creating the outcomes of the statement, okay? So you don't worry what they are. I am literally just placing a value there. So my first column, two trues, then two falses. And then my second column, I alternate true, false, true. Oops, I said it and I didn't type it. True, false, true, false. So I alternate. And what this does is it makes sure I have every possible scenario. Think of a truth table. You're not telling what happened. A truth table is creating all possible scenarios. And then once you have a truth table, you can read it and pick out the scenario you want. Just like a Venn diagram. When you created that Venn diagram, it didn't answer any question, right? But you create the Venn diagram and then you can be asked questions and you can pull the information out of the Venn diagram to quickly answer the question. That's exactly what a truth table does. You create a truth table, it covers all situations, and now I can pick out the pieces I need to answer whatever question is being asked of me, okay? So what we're gonna do is we're gonna go through our three statements up here, the conjunction, the disjunction, and the conditional, right? So the first thing I want to do is an or statement. So or is A with what looks like a capital V between it as the symbol, and then the B. So my statement is A or B. And if I write this out in words, we just did this, right? This is the spring semester has started, or quantitative reasoning is a new math class. Those are the statements we just created in 3.1. So if I come back up here to my or, it says or is always true unless all statements are false, right? So I come down here and I just go one at a time. A is true, B is true. Well, they're both true, so that means my or statement is true. A is true, B is false. Well, one of them is true, right? So at least one of them is true, then the or statement is true. A is false, B is true. Well, again, one of them is true, so therefore this is still true. And then finally, I have a false and a false. They're both false, so therefore this is false. So an or statement is only false if all the statements are false. I'm gonna pause there for a minute because I don't want to get going too fast. Any questions on why I did what I did for or?
I am trying to wrap my head around this.
Okay.
So you just made up your own truth table, the true, and the false.
Yep.
Like, so true, true, false, false.
Yep.
But it's not really based off of the sentences that we're looking at, correct? It's just because you decided to do two true and two false.
So yes and no. So it's based off the other statements based on I create the number of columns based on how many statements they are. But you are correct. It's not based off how the statements are written as of right now. So because I have two statements, I created two columns. That is the only relationship there. Does that answer that first piece? So
I think so.
if I had three statements, I would have three columns. Four statements, four columns, right?
Yep. And
Okay.
would you have done the same pattern? True, true, false, false, true, false, true, false, and then true, true, false, false, true, false, true, false? If you had
Sort
four?
of.
Okay.
I'm gonna do a 3 in a second, so you'll see it. But yes.
Okay.
And so when you're creating, remember, creating the truth table is almost like creating a Venn diagram. You're not finding that one perfect sentence because it hasn't asked a question yet. You are creating a table that covers every situation. So by creating this pattern, we are going to create a row for every possible situation that can be asked of us, right? And then once we have the table created, then I can pull out the pieces I need to look at it. So think of it as you're creating a guide, right? You're not actually answering a question here. What you're doing is you're creating a guide that can cover every single scenario that may come out of this using logic statements. So that's why I said yes and no to your question. I'm not creating a truth table to take care of only one statement. I am creating a truth table that will cover every possible statement that you could ask me. Does that answer your question?
Yes.
Okay. Yeah, so that's why I'm not putting any words to this. I'm not referring to my statements at all. Once I create my first two columns, now I am literally looking to see where is a T and where is an F. Good questions. And definitely stop me and ask these questions, please. That's the whole point of us coming together to have this at the same time, because I can fly through this and then it won't make any sense. So I'd rather have people interrupt me before I get too far. So we got or done. So now we come up here to and. And is only true if all the statements are true, right? So I come down here, I come back. So skip the or. You come back to my little greens. I come back to my starting point. So my A is true, my B is true. They're both true. So therefore my statement is true. My next row, A is true, B is false. Since one of them is false, this is false. A is false, B is true. Again, one of them is false, so this is false. A is false, B is false. They're both false, so this one is also false. So and is almost the opposite of or, right? Or they're always true unless you have all falses, which I highlighted in yellow, and is the complete opposite. They're all falses unless everything is true. Because remember, and means both must be happening. Well, the only way both happen is if they're both true. If they both don't happen, then at least one of them has not happened. Therefore, that is not an and, that is an or, hence why all my or statements are true. Questions on and? All right, break our promise one then, our implies. So an if-then statement is always true unless true, then false. So the only one I'm really looking for in this case is I'm looking for a T first, then an F. If I get a T first, then an F, then that is false. That is our broken promise, right? So I come back here, I go to my first statements. A is true, B is true. So I kept my promise. So that is true. A is true, B is false. I broke my promise, so that one is false. A is false, B is true, that is okay. So therefore that one is true. And A is false, B is false. That is okay. If they're both still false for an implied statement, so then that is also a good statement. So that is also true. So an implies is only false when the first part is true and the second part is false. Questions? Okay. So to make sure that you have your truth table built correctly, there is a little math formula, right? So if you take the number 2, it's always the number 2, and you raise it to the power, the exponent of how many statements you have, that will give you how many rows you're supposed to have here in your table. So I take the number 2, I square it because I have 2 statements. 2 squared is 4. Look at our table. I have 1, 2, 3, 4 rows. So I know I have every scenario covered in that case, right? When we get to probability, this is called the multiplication rule. We'll learn more about it in probability, but for now, it's kind of hit the Staples I believe button. Um, so that's how you know you have every scenario covered in your truth table. Now, how many columns you have comes down to how many compound statements you have. You need a column for every and, or, for every and, for every implies, if there's a not. That's how many columns you'll have. You'll have the number of columns based on how many statements you're trying to solve, but you'll have the number of rows by how many statements you have to that power. So if I have 3 statements, take the number 2, I raise it to the third power, which means 2 times 2 times 2. So therefore, in a 3 statement problem, my truth table will have 8 rows. So a couple definitions. A tautology means is when you finish your truth table and the compound statement is true in all circumstances. So it says as a statement, but it really should say a compound statement. I've created a compound statement and my truth table ends in all truths. So as my little one I have up here, these aren't tautologies. None of them ended in all truths, okay? So a tautology is true in all possible circumstances. So during the winter, it will snow or it will not snow today, right? That is true in all circumstances. And it will either snow today or it will not, right? If a snowflake drops, then it's classified by the weather that we had snow flurries, right? So therefore it snowed. If a snowfall does not fall from the sky or snowflake, then it didn't snow. So that is true in the winter of all possible situations. Now, this is a very vague one, I know that. Right? So, but that's what a tautology is that no matter what the situation is, your truth table will end in all T's. Right? So here's an example of a 3-statement truth table, right? So example, so I call this statement C, D, and E, so 3 statements. It is winter, we live in Maine, and it is snowing outside. Remember, why is it snowing outside a statement?
Is that because it could be true or it could be false?
Correct, and it can't be both at the same time, right? I can't look outside and say it's not snowing or it's snowing and not snowing at the same time. It's one or the other, right? So it's either true or false. So therefore, it is a statement. And so what we're going to do is we're going to build a truth table to answer these questions. We're going to build C and not E. We're going to build one for C or D, and we're going to build one for D implies not E. All right. And you can see I've got all these pretty highlight colors. So I think I already have the answer here in case I mess it up. No, those are other practice ones. because I'm going to rebuild this all the way from scratch anyway. So let me make sure we got this down, and then we're going to build it again, and then pray that I don't mess it up. So if you understand this, follow along with me to make sure I don't make a mistake, because it happens. So I'm going to delete everything. Delete. Oh, I didn't want to delete the rows. Undo. Just delete the letters inside. No. Why does it let me delete above and now it won't let me delete them? Fine, we'll do it one at a time. Please, no, do not do that. There we go. I can delete everything. This is when Microsoft thinks it's smarter than you and it thinks it knows what you want, but it's not what you want. All right. I messed up my table. My things aren't all lined up all pretty. There we go. Now we're pretty again. So this is back. I think it was Julie who asked, how do I know? So I am doing 3 statements. So 2 to the 3rd power is 8. So I have 1, 2, 3, 4, 5, 6, 7, 8 rows, right? So that's the first thing I do. Take how many statements I have and raise 2 to that power, to that exponent, and then I create my rows. And then I go to my pattern. So my first pattern is I do half true and half false, no matter what it is. So C is going to be 4 trues, because it's going to be half true, and then it's going to be half false. Right, and if we scroll back up here for a minute, you can see that's exactly what I did up here. First 2 true, first false, last 2 false. So first column, half are true, half are false. Then for my next one, I double alternate. So I do a true, then a true, then a false, and a false, true, and a true, a false, and a false. Is there more than one way to do this? Of course there is. You don't have to do this pattern. This is the pattern I've always done to make sure that I don't miss one, but you can do it anyway. As long as you end up with 8 full rows, then you're good, as long as you didn't repeat. And this is basically how I do it to make sure I don't repeat. And then my last one does like we just did before. We alternate true, false, true, false, true, false, true, false. And now I have every possible situation and none of them are repeated, right? So you can either write them out individually and just make sure you don't repeat, or you can find a kind of a pattern, which takes us back to chapter 1, finding patterns, right? And then we create our table. So now how I attack this problem is I do this in pieces. Do you need to do all of these columns? The answer is no, right? But I would recommend that you do more columns so you don't get confused than are needed. I only need to have 3 more columns technically because I am only looking for 3 answers. But you can see I have 1, 2, 3, 4, 5 columns because I want to make sure. Well, I have 5 because I do an extra one at the end. But I basically created an extra column for not E because that way it keeps me from making a mistake mentally that I'm supposed to always do the opposite. So because I have a not in my statements, I create a column for just that not. So not E means I look just at E and I do the opposite. So if E is true, not E is false. And then E is false, so this is true, true, false, false, true. And it's not always this pattern. I am looking at E, right? So if I would have had not D, then I would have had to look at column D and not E, right? So be very careful that you're looking at the right columns. So now I've created a column for my E. And the reason I did that is because now I can do statement 1. Statement 1 is C and not E. So I wrote it in symbols, C, my upside down V, not E. Now, if you don't want to use symbols, then put the words in your table. I am completely fine with that. It's whatever makes you comfortable. I just want to know if you can build a truth table. So C and not E. So we're back to our rules. Just to refresh, let's go to the top. And only true if everything is true, right? So we come down here. And I know you can't see what I'm doing, but because I'm comparing C and not E, I am taking my fingers and I am putting them on columns C and not E column, right? Because do I care about column D? No. Do I care about column E? No. I compare only about column C and column not E. Now I can compare these. And C is true, not E is false. Well, it has a false, so this guy is false. C is true, not E is true. Both true, so that's a true. I have a true and a false, so that is a false. I have a true and a true, so that one is true. I have a false and a false, so that one is false. I have a false and a true, so that one is also false. False and a false is false. And a false and a true is false. Because remember, and is only true if both statements, or not even both, if all statements are true. Because I could have a three statement compound and then all of them have to be true, right? Whew. Questions before we go into the next one? All right, now I'll do the second one, which is C or D. Right, and it looks like I highlighted that in a blue, so I'll highlight that guy blue to show that those are the answer in that one. So if we come back here to the top, or is always true unless all statements are false. So the only one I care about this time is if they're both false, then I get a false. Other than that, it's always true, right? So I come down here, I am comparing C or D. So I take my two fingers and I put them on column C and D. And now I just look, all right, C's true, D's true, so that is a true. C's true, D's true, so that one is also true. C's true, D's false, has one true, so it's still a true. True, false, so a true. False, true is a true. False, true is a true. False, false, there is my first false. And then false, false, there is my next false. Questions? All right, so our final one. D implies not E. We colored that guy green. So that's for this column. So now again, I go to, well, we're doing imply. So we come up here. That's our broken promise one, right? So is always true unless the first one is true and the second one is false. Then that is a broken promise. So that's when we care about false. So we want a T and F. If we get a T and F, then we know we're false. Come down here. All right, so D and not E. So I make sure I'm comparing the proper columns, because this is usually where I mess up. If I accidentally look at the wrong column, then obviously I'm gonna get the wrong answer because I'm comparing the wrong statements, right? So that's why I put I honestly, you can't see me, but my fingers are really on the screen right now just to make sure I don't make a mistake while I'm teaching this. So D, not E. So I have a true and a false. Remember, that's a broken promise. The first is true, the second one is false. So therefore that one is false. I have a true, then a true, so that is true. I have a false and a false, that's okay, so that is true. A false and a true is also okay. A true false, that's a bad guy, so he's false. True true, he's good. False falses are okay. And then I have another broken promise. Nope, false true is okay, so that one's good, so I gotta be careful. The only one should be bad are the TFs, right? So double check my work. TF, false, TF, false. Questions? All right, so this last column I added, which is not part of the problem, is a compound sentence, right? So this is saying not E, or sorry, not E. I got my symbols wrong. I'm back, or and is upside down if I forget them too. So this is not E and parentheses C or D. So I can always add on. So now to do this problem, what I'm comparing, and I'll put a draw in here, I am doing not E. So I'm comparing this column to C or D. Pick a different color. To this column. So now I take my two fingers and I only am comparing those two columns, and I am basing it on an and statement. I probably shouldn't draw like that because that looks like a triangle. So I'm basing it on the and statement, right? And remember, an and is only true if both of these are true. So now I'm comparing those two columns. So not E and C or D. So false and true. Oh, I get off draw. Like, why is my clicker not working? Work. True. False, sorry. Because I got a false and a true. So therefore that is false. I have a true and a true, so he's true. I have a false and a true, so he is false, because it's only true if they're both and. So he's true because they're both trues. He's false because one of them's false. He's true because they're both true. False, false is false because there's no truce. And then they have one of the other, so they are false. So you see, once you get the rules down, it just takes some time getting all your rows and columns in, but then it's just comparing things. And so when I created this last column, did I need to create these middle columns to answer the question? The answer is no, I don't have to. Did it make answering the question a lot easier by doing it? I hope that answer is yes, because it's much easier than going back here to the first three and doing not, E, and an or, and realizing I got to find the perfect statement that has the right pattern. Takes longer to build the extra root columns, but once you have them, then you can answer anything. Questions? Make sure I didn't miss anything.
Do we do anything else with this table, or is that would
No.
be the answer? That would be it.
Yeah, that would be it. For the homework and for the test, it's just going to ask you to create a truth table. Yep. It'll give you some. So the test kind of on chapter 3 is going to come down to asking yourself, are these valid statements? All right. So a valid statement means they must be completely true or completely false. A paradox is something that contradicts itself. And something that's an opinion is neither. An opinion is not a paradox, and a paradox is something that contradicts itself, right? So there might be a couple questions on statements. It might ask you to create a statement, a compound statement given some words, right? So there's where the negation table that we talked about here comes into play, right? So you could have some problems like, hey, here's two statements, negate it. And so you got to make sure you use the right words to negate it. And then it'll just have you build truth tables based on compound statements, which is very similar to what project 3 is under the instructor projects. For chapter 3, I ask you to create 3 statements on social media, create a truth table based on the compound statement that you came up with. And then I think I ask you to talk about, does your truth table make sense to what is to your statements? So depending on how you write your statements, does it make sense? So what I mean, does it make sense? So D implies not E. If I put that in words, right, that's what this statement is for. If we live in Maine, then it is not snowing outside, right? That is how I would take, and I think Kim asked, and we're gonna go to do some of her problems she asked about here in a minute. She's saying, is there more one way to write this? Yes, there's more than one way to write this, right? But this is how I came up with it. I went the simplest. I basically picked the fewest words I could and made sure I hit the thing. But there is more than one way to say this. But implies is the then statement. So if we live in Maine, there's D, right? Then it is not snowing outside because it is not E, and E is it is snowing outside. So you might have to do things like that where it'll tell you write a statement out where using D implies not E. And they're usually on the test and on the homework, it's multiple choice, so it's not like you have a bunch of options. So that will be a little bit beneficial in that aspect. It will help limit the possible answers we can get because it'll be multiple choice.
Would it also be the correct
Say again, you got real quiet.
Sorry. If we changed if to because or any
Yep.
other word?
Yep. Yeah, if you use this, I think it's called a synonym, and I can't even say the word. If you pick a similar word that will go with something more, then yes. Yeah, because there's a lot of different words for and, both, I'm trying now. I said there's a lot of words. I can only come up with 2, but yes, as long as you pick because, if, therefore, then, implies.
Okay.
Yep. That's why in the test, these questions will purposely be multiple choice to make grading easier on me, because then I limit your options, where 1 is correct and 3 are not. Is there more than one right answer? Yes, and that's again why some people like this class, because there is more than one right answer. And then some of you don't care for this class because you want just the one way to do it that always works. And unfortunately, because we're taking math and grammar and combining them together, it doesn't always happen that way. Just like my pattern I taught you is not law, right? You do not have to do the way I did it. What you must do is be able to create the proper number of rows, and the multiplication rule will tell you how many rows. And then you just got to make sure that you put the pattern in there so you don't repeat a pattern. My little trick is just a trick I came up with that makes sure that I don't repeat a pattern. And so if I follow that pattern every time, I know I will get out all possible cases without repeating. But it's not the one and only answer. Now, once you get into the compound statements, yes, that is the one and only answer. Yours might not look identical to mine, because if you don't create your rows in the same order, then the T and Fs might be in a different order. But in the end, we should have the same amount of T's and we should have the same amount of Fs, in the same alignment. And if we do not, then there's something wrong. But it might not look identical and still be the correct answer. So typically, if we're time and I was in the classroom and I can kind of make you work, then I'd have everybody break into groups and come up with their own little truth table. But because we're in Zoom and it'd be a little more challenging, I think we will stop here. And I will go and answer questions. And so I know Kimberly's asked about 2 questions in the book, which I made sure I had today. So that is the end of the lecture. So you don't have to stick around if you don't want to, but if you want to stick around for questions and see what we're working on, then I am fine with that as well. But that is the end of new material. So Kimberly, so if you have your book, what we're looking at, and I'll put it on page 98. And I'll put it up in case you don't have your book so we can see it too here in a minute. And I'll put it up, I'll have to write it up because I don't have a digital book up right now. So page 98, problem number 25. Yeah, mine's on number 98. So mine's actually on page 97, 25 and 29. Well, mine's actually on 96. All right, so let's see, where can I put this? We'll go below this. Great, there we go. So number 25 in section, I'll just do section. So section, oops, I forgot my cap lock was on. Section 3.1, what it wants us to do for number 25. So number 25, no, can't spell or number 25. It wants us to negate the statement. All right, so the statement is statement A. I hate that my thing capitalizes. It's not supposed to capitalize. There we go. Statements aren't capitalized. A. Kelsey's website had more than 50,000 visits yesterday. All right, so it wants us to negate the statement, right? So negate. It's hard to type with a book under your forearms as you're typing and reading. All right, so negate it, negate A. So how would we negate this? Any ideas?
So the answer says instead of the word had, did not have.
Oh, okay. Yep, that would work. Yep.
I guess my question was more of like, I focused in on the word more.
Okay. So what was your statement?
Well, I wanted to use something other than the word more with a single word. So like I would say less because that is an opposite, but that isn't what the book had.
I'm fine with, yeah. Your less is close. So let me fix your less, but your less is very close. So Kelsey's website had at most 50,000 visits. God, I can't type in with the book underneath me yesterday. So the issue with your less is it left out 50,000. Right? Because since it's more than 50,000, 50,000 is not included. So if you do less, we still have one value that is not included in either statement, and that is the number 50,000. By doing had at most, that is now everything less than 50,000, but also includes 50,000. So yes, there's more than one way to write it. Well, you have to be careful with the negate statements is you must be completely opposite, which means you have to include everything that the statement does not, right? And that's what makes it hard. And that's why I like this table, because I got them wrong. I get them wrong once in a while because our mind just says, if I say all, well, to us, the opposite is none, right? But if you think about it mathematically, it's not. All I need is one of those not to be true, right? And so that's kind of where this comes in. So most isn't in here, but we're kind of doing, well, not even at least, so most ain't even on this table. So you could always add to this table to make sure if you want to, right? But that's why this one, come back down here. 50,000 is not included in the first statement, so therefore I just need to write it somehow that 50,000 is. So you could have wrote yours, Kelsey's website had 50,000 or less visits. That would also have been a true answer. Yep. Any other questions for anyone still on?
I had a question on that one. Sorry, I had to step up for a second.
Nope.
But could it be less than 50,000? Would that make it?
It would be close. So that's the same thing that Kimberly said. The reason less than 50,000 doesn't work is you leave out the number 50,000. Since 50,000 is not included in the original statement, then I have to make sure it's in my negation. Yes, Mary, I agree with you. It is the wording, right? And so that's why I'm happy people are asking and we're talking about these. That's what's tough about this class when people realize that, like, it's not even the math in this class that makes this class tough, right? It ends up being the grammar and the words. And if you take statistics, it's very similar. That's why I think this is a great class before statistics, because it's not so much the math that makes this class challenging. It is the wording. So to do another example of this one, to get this to be example to less than, I got to figure out, turn off my auto capitulate on my thing. So say we have Kelsey's website had at least 50,000 visits yesterday. Then the negate of that one will be the one that you all want to do now, because 50,000 is included in the first statement. Now my negation will be Kelsey's website had less than 50,000 visits. Oh, God. I need a bigger desk when I'm in the office. Now that one will be a less than, because 50,000 is included in the first statement. At least means that number or more. So therefore, the opposite would be less than that number. Great questions. Do we have all the problems to 25 this week? Sure, I'm okay with that. Just let me move my boxes so we don't lose them. All right, so what I'm going to do then is to save me of my typing errors. I am going to type up 26 through 30 and give everybody a chance to kind of think about them, and then we'll come back and talk about them. How's that? So here's number 26. Again, these are all negate statements. So 329 people applied for same job I did. You have some gaps, so I can put a statement in there. Number 27 is I did not get the job. Number 28. I don't know why I'm putting them on a different line. I can just keep on the same line. Austin slept until 8 a.m. and no, this morning. Number 29. None of the Christmas tree lights are not working. Ooh, that's a weird statement. Let me do this to save some space. 26, I'm put on the same line. All right. Okay. One more. Okay. And lastly, number 30. Every student is volunteering at the food pantry this year. All right, now I can get this book out of my way so I stop making mistakes. Oh, and I'm typing. Okay. I almost feel like I'm actually in the classroom. I love it. So, anyone have an answer for 26?
Could you replace the words the same at the end of the sentence with a different job than I did?
It's so funny, Kimberly, because everything I'm thinking you're saying, so this is great.
Yeah, this is, I'm really good at grammar, but this is a stump one for me. I don't understand these very well.
So 329 people applied for a different job than I did. Is that what you said?
Yes, so the sentence would read as a negated sentence. I would read it like 329 people applied for a different job than I did.
Okay. I cannot see anything wrong with this. And so how I'm checking these and getting picky is basically you're proven by contradiction here. If I can find one example that does not fall in either one of those spots, then we don't have the complete opposite, right? That's how I did the last one. I found how 50,000 didn't fall in one of those places. I'm looking at this and I am not, unless someone else sees, please speak up, because these are tough. I can't see yeah, I got one. We're missing the people who didn't apply for any job.
So then would you say all but 329 people applied for the same job I did?
So all but applied for the same job I did. Yes, because now that takes everybody else is in the opposite. And so the book's answer, which I don't like, I'll be honest, 329 is not the number of people who apply for the same job I did. That just doesn't sound grammatically good, so which my statement just didn't sound much better than that either. But so their book's answer is 329 is not the number of people who applied for the same job I did. Yeah, I like yours way better than the books. I can tell you that right now. That just reads to me weird.
The book's answers are all like that for me.
Yeah, I don't like that one.
Okay.
I would have probably come up with at least one person didn't apply for the same job I did. At least is my go-to, because when you get, if you take statistics with me, you'll see I use at least all the time, because at least is the easiest way to do the opposite, because then I have one that did not do it. So at least one person did not apply for the job that I did. Now that at least covers everything else. That would have been my statement. But yours is perfectly. Write it out. Yep. So this is, I'm gonna put this in the answer. This is the book answer, which I don't care for. Mine would have been at least one person did not apply for the same job I did. Yeah, lots of different answers. The key is trying, when you do it, when you write out your statements, then just ask yourself, is there someone missing in one form or the other? Right, that's the kind of the negate, because you need the complete opposite. I think 27 is a little bit easier. Anyone have an answer for 27?
Wouldn't the opposite be getting the job? Like
Yep.
I did? Okay.
Yep.
It seemed like too easy of an answer.
No, that's sometimes, yeah, sometimes this one's not bad. I did get the job, because this one is a little bit easier to the opposite, because you either got the job or you didn't, right? It doesn't say you took the job. It says basically I did not get the job, or I got offered the job, right? So one of the two things happen. You either get offered it or you don't. So this one's a little bit easier. Those are the easier ones when it's this or that. There's no gray area or in kind of thing in between. That one that I think's pretty that. Yeah, 26 was a challenging one because of just the wording. All right, how about 28? Well, let me put a negate by that, so if someone goes to my notes later and like, what is he even talking about? Negate. Zach, so just talking about yours when you wrote, how about did not apply for the same job? Oh, you're on the other one. Yeah, perfect. That would have good. Yep. Sorry, I didn't see Zach's comments until now. Good job, Zach.
Could 28 be
mhm.
Austin was awake at 8 a.m. this morning?
Oh, okay. Oh. Austin. I don't know why I put Austin in there. Austin. Okay. So you said Austin was awake at 8 a.m. this morning. Yeah. I can't think of anything opposite of that. That's not covered because you're either sleeping or you're awake, right? I mean, there's times that we could probably argue if someone's actually awake, but yeah, by definition, you're asleep or awake. So if you're awake at 8 a.m., then you're not sleeping at 8 a.m. I like that one. That's a good one.
I like that, Julie. Could you also say Austin did not sleep until 8 a.m. this morning?
Yeah, Austin did not sleep until 8 a.m. this morning. That's a good one. Actually, I think that's the answer the book uses as well. more.
I believe that our book only gives us the odd answers.
Yeah, it does. That makes it so us lazy instructors don't have to come up with our own problems. I don't use the books. That's why every time you ask me, I actually have to read it. I don't use book problems. I make my own up. So no matter what you ask me, I'm like, what? Let me look at that. So sometimes I'll know the answer quickly, and other times I'll be like, what is this even asking me? Yeah, I don't use the book's problems. I use the book's definitions, but I don't use their problems. Nice. Good job. 29. Oh, no, that's none. There we go. Of the Christmas tree lights are not. That just seems like a weird sentence to me all around, but that's how the book wrote it. None of the Christmas tree lights are not working.
So could this one be all of the Christmas tree lights are not working?
That is close, but it's not the complete opposite, because none of the Christmas tree lights are not working. All I need is what?
One.
I only need one of them to work. I don't need all of them to work to be the opposite. I need one. So this is my favorite one.
At least one of the Christmas tree lights are working.
Yeah,
Okay.
at least one of the Christmas tree lights are working. There's multiple ways to write this one. Christmas tree lights are working. Another one could be what?
Could it be only one of the Christmas tree lights are not working?
Yes, that's actually, I think, what we're supposed to have. I'm reading this because this none. It's basically like that double negative, which we teach in grammar never to use. They purposely put it in here. So none of the Christmas tree lights are not working is basically saying what? All the lights are working, right? So by saying at least one of the tree lights are working, that doesn't come up for the not. So this is actually not a correct answer because of the double negative in the statement. I'd have to put in not. At least one of the Christmas lights are not working, because in this statement, what it's really saying, all are working. Just horribly written to try to confuse you, right? That statement actually is saying all the lights are working. So I need at least one of the lights not to work to be the opposite. Catherine said, let me write hers out so everybody can see it. I guess everybody can see it's in the chat, but I'll still write it out. One or more of the, perfect, lights are not working. Perfect. Yep, that would be a good one. I actually like that one better than the other one. You could write some of the lights. I guess I should put Christmas tree and all that in. I'm getting lazy, but some of the lights are not working. Because all you need is one or more not working, right? Which is exactly what Katie said, one or more. So a couple different ways to write all these negates. Negate. Oop, I don't want to do that. Negate. Negate. Okay, last one. Every student is volunteering at the food pantry this year. None, no students, there we go. No students are volunteering. No, we are still recording. This is good for anyone who wants to watch this later. At the food pantry this year. Close, because this is, you're missing the partial piece, right? Because the first one is all, this one is none. What we're missing is some. So Zach is correct if we add the statement not all students. Now we've covered everyone, which is what David covered if no one volunteered, but we got to get the students that are in between, because basically we're at the two extremes. No students, the far left extreme, every student, the far right. We're missing the middle. So like Zach said, if you bring in the word not all, now I'm covering the middle. So not all students are volunteering. I just need at least one of them not to show up. And now I've got the opposite. All right, and then again, my favorite, negate. At least one student is not volunteering at food pantry this year. Nice work, everyone. Oh, okay,
Can we
good.
go over some of the ones right before that too? The reword each conditional statement? Just at least one,
Yep.
just to kind of see.
Yep. So so we just keep these things in order. Section 3.1. But I never negate the statement. All right, so we're still in section 3.1. So this one wants us to reword each conditional statement using the specified alternative phrasing. Wow, I missed some. I definitely didn't hit the keyboard hard enough, I guess. Okay, so these are numbers 20 to 24. All right, so I don't even know what this is asking quite yet. So let's see here, number 20. Use the form Q, not use he. Use the form Q. I don't know what Q is. Oh, Q whenever P. My fingers are off in the keyboard, I guess. Use the form whenever P in the statement. If I flip the switch, the lights turn on. If I flip the switch, the lights turn on. So it wants us to rewrite this with whenever. So replacing the if then, so it's not the lights turn on. So it wants us to replace the if the with whenever is what it's telling us to do.
So would that just be whenever I flip the switch, the lights turn on? Or does it have to be in both spots?
I would take out the word, it wants to take out the word if. So whenever I flip the switch, the lights turn on. So the book's answer, let's see how close I was. The lights turn on whenever I flip the switch. Basically, this thing is saying the same thing I said, but let's see. Make sure, have everyone look at it grammatically and make sure I didn't mess up. No, the lights turn on whenever I flip the switch. No, not flop. Yeah, I'd say those two things are saying the same thing. If anyone disagrees or something, please speak up. But yeah, that's what they're asking to do here. That is replace this word in the statement. Oh no, okay, I got it now. On mine, this one is wrong. The first one is wrong. I see why. So that's what they want us to replace those words. But we got to be careful. They weren't clear in this, but now I see what they're saying. They're arguing that this is statement P because it's first, so it's first in the alphabet, and this is statement Q. It doesn't actually clearly state that in the book, I don't believe. I don't see it that way. But using the basically understanding of the alphabet, P becomes before Q. So they're saying this first statement is P, and they want you to actually swap them. They want Q to be first, then P. So they don't want us to use this statement, because this statement is P, because there's the switch and there's Q. So even though I use the right word, I didn't swap the statements. It wants me to also swap the statements because I see Q's first. So now you can see here is Q, and this is P. So we actually use the word and we put it between Q and P. So even though we got the wording right, what the book is saying is make sure that they look more like an A. Put a little tail on it. Is they also wanted us to swap the statements around. Does that make sense?
Yes, that makes,
Yeah.
yep.
Yeah,
Yep.
I missed that part. I was focused on the whenever, and I was like, oh, that's easy. Just take a if and the, but they also want us to flip the statements. So since I missed that one, I'm just doing it now. Get how to draw. And enter. So let's try another one. I'm going to do the even ones. That way, if you guys want to go back and look at the odds, you have the answers to. Number 22, use the form P. Yeah, they're all in order now. So 23 swaps them again. Use the form P is sufficient for Q in the statement if I pedal faster, then the wheels turn more. Oh, my fingers got off the keys again. Slowly. Pedal, turn. If I pedal faster, then the wheels turn more slowly. Okay.
It's not a big deal, but that's question number 21, not 22, just in case somebody comes back to it.
Oh, thank you. So let me change that. I just gotta take this one word out because I didn't realize it's the same statement twice. No, it is. So that is 21. Dang it. All right. Well, I'm just gonna go with 21 now. I said 22 and then I didn't do it. So 21. Use the form P is sufficient for Q in the statement. If I pedal faster than the wheels, yep, that is 21. So it wants me to replace the if then with sufficient. This is a weird, I don't know if I'd ever use the word sufficient in here, but I actually had to look at the answer because I couldn't see it. And I'm like, how would I use sufficient in this statement? But so I cheated. I looked at the answer. Anyone think of anything since you can't cheat like I did?
So I did cheat and because I didn't figure it, I wrote it out differently, but the answer is my pedaling faster is sufficient for the wheels to turn more slowly.
Yeah, my pedaling faster is sufficient for my wheels turning. Is it turning more slowly? Yep, turning more slowly. Yeah, sometimes replacing with what they want you to doesn't really make the sentence better. In this case, I would argue that. But the key is making sure that we're still in the right order, right? So this is P because it's the first statement. This is Q because it's the second statement. I'm still in the right order, so P is first. Q is second, and I replaced if and the. Find my highlighter. I replaced, come on mouse, where'd you go? There we go, finally. I replaced if and then with the word sufficient. Ooh, I don't like how that highlighted, but we'll go with it. Yeah, so there's some good ones there. Like I said, they're going to the 3.1, we could be kind of playing with this in the section. And then again, if you go into the review, there'll be a little bit of each section versus staying in 3.1. It'll be just specific to 3.1. Good questions, though.